Dear all, this video discusses how to find autocorrelation of a sequence. So correlation is used to find out the relationship between two sequences. So there are two types when you're finding out correlation, that is autocorrelation and cross correlation. So autocorrelation is used to find out the correlation between the same sequence. So the general way of writing it is given as x of n into, that is convolution of x of n into its reflection. So basically autocorrelation means if you take a sequence, you will just flip it, or the reflected part of the same sequence is taken, they are both convoluted, and you obtain the final result. So it's very similar to linear convolution, where the sequences considered are the same. Now in order to write the program in Matlab, the first step is CLC, that is in order to clear window, it can be written as CLC, then clear all. Clear command window, the command is CLC. Then to clear previously used variables, clear all. In order to close the previously opened figure windows, close all. So now here in autocorrelation there is only one sequence. So the correlation between it, so directly give x is equal to input of, enter the input sequence x of n. So now the length of the sequence can be found out using the command length of x. Now the autocorrelation function is based. So suppose you consider a function x equal to this value. Suppose you want to flip it. So we have to obtain x of minus n. So in order to obtain x of minus n will be the opposite of x. So there is a command in Matlab known as flip LR of x. So this will flip the function. So you are obtaining here x of minus n. So the equation is given as x of n in convoluted with x of minus n. So now once you have obtained x of n and x of minus n, so next step will be to convolute both the sequences. So which can be achieved by using con function. Con function. So once both the functions are available, that is x denotes the sequence, h denotes the flipped sequence x, that is x of minus n. So the next step is convoluting both the sequences. So that will give you the autocorrelated result. So Rx is equal to conv of xh will give you the autocorrelation result. So disp of the whatever you have written in single quotes will be displayed in the command window, and disp of Rxx without quotes when you write, the value of Rxx will be displayed in the command window. So autocorrelation is similar to linear convolution. Only thing is the sequences that has been considered is the same sequence. So linear convolution length is given as L plus M minus 1. So here as it is the same sequence, length can be taken as Lx plus Lx minus 1. Also there is a built-in function given in Matlab, that is x core of xx. This will give you the inbuilt function result. So again to display it, it can be given as autocorrelation. So whatever you write inside the single quotes will be displayed in command window, and disp of z will give you the value of z. Now in order to write it without any functions, so similar to how the program is written in linear convolution, same program can be used here. So considering the same steps what is followed for linear convolution, it can be written as for n equal to 1 to length, Rxs of n is equal to 0. For k equal to 1 to Lx, if n minus k is, so if it is between 0 and Lx, then the function, that is convolution function, has to be executed and the values has to be stored into the variable. So here this is initialized. Initially the variable Rxs of n equal to 0 is initialized, then later it is used like a recursive function, and all the values of what you obtain from this equation, from this, is stored into Rxs of n. So if condition has to be given an end, and for loop also an end has to be given. So this result can be displayed using disp function. Now in order to plot the graph, so here we have to plot the sequence, then the RxX values. So just consider A is equal to 0 to length of x. So as we are starting from 0, it has to be taken as Lx minus 1. Then give subplot. Subplot is used to divide the graph into here 2 rows and 2 columns, and we are plotting the graph with A as x-axis and x as the y-axis. Stem is used to get the discrete plot. Then title, x-axis label, y label are used to get x-axis, y-axis and title. So similarly we can plot all the values. So B has to be given as minus of Lx minus 1 to Lx minus 1. So here all the autocorrelation functions are plotted. Now in order to verify the result, so run the program, add to path. Now give the input sequence. Let us consider a symbol sequence 3, 4, 5, 6. So the results obtained are like this, and also all the graphs are the same. So this is the output, so it is verified as all the results are the same. Sequence has to be considered as 3, 4, 5, 6, and the other is the flipped sequence, which is 6, 5, 4, 3. So first value will be 6 into 3, 18, 6 into 4, 24, 6 into 5, 30, 6 into 6, 36, 5 into 3, 15, 5 into 4, 20, 25, 5 into 6, 30, 4 into 3, 12, 16, 20, 24, 9, 12, 15, 18. So now here this values will be equal to 18. So the final result will be 18. 24 plus 15, it will be 39. Then this will be equal to 50, 62. Then 36 plus 25 plus 16 plus 9, 86. Then 20 plus 30, 50, 62, 39, 18. So this is same as what has been obtained in Matlab. So it is verified theoretically also. So please do share, like and subscribe to the channel for latest updates.